I'm a biological engineer, and my wonderful group sitting in the back there is focused at unraveling one of the most mysterious materials in biology, mucus. Mucus is not only incredibly important for your health, it also is home to the smallest wild things we know, bacteria. So my story starts 340 years ago when Anton van Leeuwenhoek created a lens so powerful that he discovered a mysterious new world populated with tiny creatures, funky creatures, just like these. Some of these critters are really helpful for humankind, but others are ferocious and can cause together more deaths than any war. But almost exactly 100 years ago, we discovered antibiotics. This has been the magic bullet. This has been finally a way with which we could combat microbes and some of the most deadly ones. But it is also an arms race because antibiotics cause evolutionary pressure on microbes and drive them to building resistance. And we now have superbugs. Superbugs are of growing concern. And so what's next? Imagine we could step out of the arms race and instead build an alliance with these problematic microbes. Imagine we could domesticate them. We build them a home, we give them food, and in return, these bugs agree to help protect our health or even equip us with new functions. I want to tell you about mucus now, an unsung hero who's been taming microbes, problematic microbes, for millions of years. Mucus is really the location and battleground of our interactions with the microbial world. Mucus lines all interior linings in your body that are not coated by skin. This amounts to about 2,000 square feet in the digestive tract alone. And you produce about a gallon of mucus every day. Mucus fulfills many different functions. For example, it helps preserve your moisture on your eyes, your nose, your lungs, and it also helps your stomach protect itself from digestion. But mucus is also an ecological niche, a major ecological niche for microbes. You have trillions of microbes growing on you and inside you. In fact, you consist of more microbes than human cells, and many of these microbes live in your digestive tract inside the mucus. Many of them are really important for you. They help you build vitamins, they help you digest food, and some of them even help you protect yourself from other damaging microbes. So mucus forms a habitat in which these beneficial microbes can thrive and benefit the body. They have no incentive to leave. They have a safe place to live and food. But in this crowd are also potentially harmful pathogens that can cause infections. Over millions of years, mucus has evolved the ability to keep problematic pathogens, certain problematic pathogens, in check. And important here is that this mechanism is not based on killing the microbes, but instead it tames them. And mucus tames these microbes by mucine polymers. These are the gel-forming building blocks of mucus. These look like little bottle brushes that are densely grafted with sugar molecules. And these sugar molecules, with these, it can interact with protective molecules, for example, from the immune system, but also with microbes. And this helps keep us healthy. And the reason for this is that microbes really want to eat and divide. They don't want to harm us. This is why presenting to them something like sugar can help. It is food for them. And it is maybe not unlike a child will stop fighting when you give her a lollipop. Dysfunctional mucus can lead to a number of known diseases, for example, cystic fibrosis, ulcerative colitis, dental cavity formation. And I'm so excited about mucus because I'm convinced actually that it can help us find new ways of protecting our health and protecting ourselves from infections. So my lab and others around the world have begun to synthesize mucines and mucus, and we want to use engineered mucus to control problematic pathogens and stop the growing threat of antibiotic resistance. But we also want to use engineered mucus to domesticate microbes which could potentially help humans thrive on the planet. Imagine we could learn how to stop the arms race. These critters could help us adapt to harsh conditions and, for example, help us build food in the digestive tract. This could solve starvation. Microbes could also help us become more salt tolerant. Imagine we could drink salt water. This could solve the drink water problem. And microbes potentially could also help us tap entirely new sources of food by extracting nutrients and minerals from materials which we don't currently think of as food, such as substances found on other planets. This could help us colonize new planets. Now, this may seem a bit far out, but remember that bacteria live in all sorts of places we consider uninhabitable. For example, geothermal vents. And if they live there, they can extract nutrients, minerals from materials in their environment, and they can feed us too. 340 years ago, Leeuwenhoek discovered a mysterious new world with tiny wild things, and more recently, we learned that these wild things live with us in the ecosystem of our body, inside our mucus. By engineering mucus, we have the possibility of domesticating microbes, opening an era of new opportunities for mankind. Remember this next time you blow your nose. Thank you.